Have you ever wondered why continents seem to fit together like puzzle pieces? Or why fossils of the same ancient creatures appear on land separated by vast oceans? The answer lies in one of the most fascinating scientific theories of all time, the Continental Drift theory. In this video, we'll explore the origins of this theory, the evidence behind it, and how it reshaped our understanding of Earth's history. The Continental Drift theory was first proposed in 1912 by a German scientist named Alfred Wegener. He suggested that the continents were not fixed in place but had slowly moved across the Earth's surface over millions of years. According to his theory, all the continents were once part of a single massive landmass called Pangaea, a supercontinent that existed around 300 million years ago. Over time, Pangaea began to break apart, with the continents drifting to their present locations. But in the early 20th century, this idea was highly controversial. Most scientists at the time believed that the Earth's land masses had always been stationary. So what evidence did Wegener have to support his radical idea? Although Wegener's theory was initially dismissed, he gathered multiple pieces of evidence to support his claim. Let's take a closer look at some of the most compelling arguments for continental drift. If you look at a world map, you'll notice that the coastlines of continents, particularly South America and Africa, seem to fit together almost perfectly, like pieces of a jigsaw puzzle. This similarity suggested that these land masses were once joined and later separated. Scientists discovered fossils of the same species of plants and animals on continents that are now thousands of kilometers apart. For example, the extinct reptile Mesosaurus was found in both South America and Africa, even though it could not have crossed the Atlantic Ocean. Similarly, fossilized remains of the plant Glossopteris were found in Africa, South America, India, and Antarctica, further proving that these continents were once connected. Geologists found that mountain ranges and rock formations on different continents shared striking similarities. For example, the Appalachian Mountains in North America align perfectly with mountain ranges in Scotland and Norway. Another key piece of evidence comes from ancient climate records. Fossils of tropical plants have been found in Antarctica, indicating that this frozen continent was once much warmer and located closer to the equator. Similarly, glacial deposits in Africa, India, and South America suggest that these regions were once closer to the South Pole. Despite this strong evidence, Wegener's theory faced a major problem. He couldn't explain how the continents moved. He suggested that the continents plowed through the ocean floor, but scientists argued that this was physically impossible. Without a clear mechanism, his theory was dismissed by the scientific community for decades. It wasn't until the 1960s, with the discovery of plate tectonics, that Wegener's ideas were finally accepted. Scientists found that the Earth's crust is divided into giant plates that float on the semi-molten mantle. These plates move due to convection currents within the Earth's interior, providing the missing explanation for continental drift. Today, the continental drift theory is a fundamental part of our understanding of geology and Earth's history. It explains why earthquakes and volcanoes occur along plate boundaries, how mountain ranges are formed, and even how ocean basins open and close over millions of years. It also helps us understand the distribution of species, the formation of natural resources, and even how Earth's climate has changed over time. What was once a controversial idea is now a cornerstone of modern science. So, what do you think about the continental drift theory? Were you surprised by how much evidence supports it? Let me know your thoughts in the comments. If you enjoyed this video and want to learn more about Earth's history, don't forget to like, subscribe, and hit the notification bell so you never miss an update. Thanks for watching, and I'll see you in the next one.